All right, so this lesson is on solving systems using substitution. And specifically, we're talking about systems of linear equations. In a previous lesson, I talked about how to solve systems using graphing. So I'll put a link up here in the upper right corner if you'd like to go look at that. So this is going to talk about how to solve systems using substitution. And for most of my students, this is their favorite way of solving systems of equations. So you have the choice of using graphing, using substitution, and then the next lesson I'm going to teach is on, now my mind just went blank, elimination. Yeah, so graphing, substitution, and elimination. And substitution is the favorite one of most of my students, although a lot of times it's easier to use elimination. All right, so a system, solving a system. So first of all, just real quick, again, a system of equations is just two or more linear equations. So these two equations constitute what we call a system. Finding a solution to those is finding an XY ordered pair that is a solution to both of these. All right, now when we graph them, we look to see if they crossed, and where the two lines crossed, that was the solution to the system. So in substitution, what we're going to do is we're going to substitute. Imagine that. And so we're going to take these two equations and we're going to substitute one of the equations into the other equation. And so what that means is right here I have y equals 3x. Y equals 3x. So what I'm going to do is take that, and in the other equation, I'm going to replace y with 3x. Because the first equation says y is equal to 3x. That means they're the same thing. So that means down here I can replace y with 3x. All right, so that's what we're going to do first. So I'm going to plug that in here, and that's going to give me x plus 3x equals negative 32. And the point of that is to give me an equation with just one variable, so I can solve this equation and find out the value of that variable. Now that value of x will be a value of x that both of these equations share. So I solve this, x plus 3x, that's 4x, so I combine like terms. Solving for x, I want to get rid of the 4, so I see multiplication and I do division. And so here's half of my solution, x equals negative 8. Now I just need to find out what y is equal to. All right, so now I'm going to take that equation, y equals 3x. I don't know if we're going to. This is what happens when I do my lessons on Sunday afternoon. It's Easter today, so happy Easter if you happen to be watching this on Easter, which the odds of that are not very likely. So now I'm going to take x equals negative 8 and I'm going to plug that in for x. So this says x is negative 8, so let's plug in negative 8 and let's see what y is equal to. So that's going to give me y equals 3 times negative 8. So y equals negative 24. So the solution to this is negative 8, comma, negative 24. And so what that means is that I can check this, okay? This is my solution. This is an XY ordered pair. And I can check it, and I can plug in negative 8 into these two equations and see if y is equal to negative 24. So if I plug in negative 8 to the first equation, 3 times negative 8, that's equal to negative 24. Check. That's good. This equation, x plus y equals negative 32. So is negative 8 plus negative 24 equal to negative 32? Check. Yes, it is. So this is a solution to both of these equations. So that's substitution. You take one of the equations and substitute it in to the other equation. So let's look at another example. Y equals 2x plus 7. y equals x minus 1. So I have a choice here. I can plug this, so I can replace this y with x minus 1, so substituting this equation into this one, or I could take 2x plus 7 and substitute that into this equation for y. Either one would work. For me, x minus 1 just seems simpler than 2x plus 7. So I'm going to substitute that in to this equation. So that's going to give me x minus 1 equals 2x plus 7. So I just replace y with x minus 1 since y is equal to x minus 1. All right, so let's solve this. We got variables on both sides, so we need to get the variables on the same side. So remember, you can either subtract x from both sides or you can subtract 2x from both sides. So I'm going to subtract x from both sides because that's going to leave me with a positive coefficient on the x. This minus sign doesn't go away. A lot of students miss that. So this becomes negative 1. 2x minus 1x is just 1x or x plus 7. Subtract 7 from both sides. And I get x is equal to negative 8. All right, so there's one of my solutions there. All right, so now let's take this and plug it into the first equation here, or the one I have circled. All right, so I'm going to plug in x equals negative 8, so I'm going to replace x with negative 8. So that one now, I have, so I'm taking this equation, y equals x minus 1. I'm taking this and plugging it in for x. Now, one thing I want to point out here, notice the first time I took this equation and plugged it into this one. And then the second time, I took this and plugged it into that one. So as far as plugging in, you should try to plug into each of these. So like the first time you plug into one of the equations, once you get your answer, plug it into the other equation. I don't know if I made that clear or not. So what I mean is I didn't plug negative 8 into y equals 2x plus 7. Because I already used that one, plugging in the x minus 1. It'll work, by the way, but if you make a mistake somewhere, so I use this equation to find this value. I'm better off using the other equation to find the y value, because if I made a mistake the first time, it will help me catch that. Okay, so I'm going to plug in negative 8 for x. So y equals negative 8. That's an 8. In my hand don't always go together here. So y equals negative 9. So there's my x and y ordered pair. That's my solution. So the answer is negative 8, negative 9. That's a solution to both of these. And again, you can check it. So this is an x value, this is a y value, right? So plug these into the first one. So 2 times negative 8, that's negative 16, plus 7 would be negative 9, which is what y is supposed to be equal to. The next one, plug in negative 8 for x. Negative 8 minus 1 is negative 9. That's what y is supposed to be equal to. All right. So let's look at another one. All right. So if you notice on the first two we did, at least one of the equations was solved for a variable. So it made it really easy to substitute. On the first one, notice y was equal to 3x, and that's the one I used to substitute in. The second equation wasn't solved for a variable. So what you want to do if one of your equations isn't already solved for a variable is you want to solve it for a variable before substituting. And it doesn't matter if you solve it for x or solve it for y. But if you're faced with a situation like this, with this system, the easiest thing to do is to take this one and solve it for x. Solve it for x. And the reason that's the easiest is because all I have to do is subtract 3y from both sides to get the x by itself. If I was to solve one of these other equations, or if I was to solve this one for y, I would have to subtract x, and I would have to divide by 3. So it'd be more work. So solving for x, all I have to do is subtract 3y from both sides. So let me do that real quick. X plus 3y equals -7. So subtract 3y from both sides. I didn't mean to make this here. So subtract 3y. Those go away. X equals -7 minus 3y. So now I want to take this and I want to plug it in to the other equation. Don't plug it into this equation because that's what this and this are the exact same thing. So take this and plug it into the other equation that I haven't used yet. I'm going to replace x with -7 minus 3y. All right, so this one's a little more complicated than the first two. So 6y plus 5 times -7 minus 3y. So I replaced x with -7 minus 3y equals 8. Now I have a multi-step equation. The first step is to distribute. So 6y minus 35, because this is a +5 times a -7, minus 15y, because of this minus and a plus, make a minus, equals 8. Combine the like terms. This is 6y minus 15y. So 6 minus 15 is -9. Minus 35, so I just bring that along, equals 8. Two-step equation now, add 35 to both sides. So 9y equals 43. Sorry, hold on 1 second. I'm trying to do something. My mouse isn't working. Oh, I figured it out. All right, so divide both sides by 9. And so what I get is that y equals 43/9. All right, so I'm halfway there. So now we're going to take this and plug this in to the other equation. Plug this into here. So now I have x plus 3 times 43/9 equals -7. Multiply these together and you get 43/3, because the 3 and the 9 will simplify to 1 and 3, equals -7. Subtract 43/3 from both sides. Don't be afraid of fractions. They won't bite you. -7 minus 43/7, or 43/3. I've put 7 there, sorry. 43/3. You can put that in your calculator and you get 22/3. So there's my x value. So now I have the x and the y. That's a solution to these. So my solution is 22/3 over 43/9. And for the sake of time, I'm not going to check this, but you could plug these in and make sure that it's a solution to both of these. All right. So I have lots of examples here for you, okay? Now, this one is already solved for x, so that's a nice thing. So now I just have to take this, plug this in for x in the other equation. So I'm going to plug that in here. So x is equal to that. So I'm going to plug that in for x. And so I get 3.5 times -2y plus 4 So I was just replacing x with that. Plus 7y equals 14. Distribute, that gives me negative 7y plus 14 plus 7y equals 14. Combine like terms, negative 7y plus 7y, those are going to cancel each other out, so that's 0. And I end up with 14 equals 14. So remember, when you're solving equations and you come up with this, what that tells you is that there are infinitely many solutions. And what that really means is that these two equations are actually the same thing. So these equations are actually equivalent. So if your variables disappear and you're left with a number equals itself, then it's infinitely many solutions. Now, if this said 14 equals 12, that would mean there's no solutions to this system. Now, if you've done the graphing lesson, what that means is when you graph these two lines, they actually are the exact same line. All right, so let's look at the next one. It's already solved for y here, so I'm going to take this and plug it in for y. So I get 3x minus 11 minus 3x equals negative 13. So I just replaced y with 3x minus 11. 3x minus 3x, combining like terms, those cancel each other out. And I'm left with negative 11 equals negative 13. When that happens, that means there are no solutions to this system. All right, so you can have one solution to the system, you can have infinitely many solutions, or you can have no solutions. So this means there are no XY order pairs that are a solution to both of these. All right, last piece here, a word problem, everyone's favorite. A snack bar sells two sizes of snack packs. A large snack pack is $5 and a small snack pack is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs did the snack bar sell? So the topic here is systems of equations. So that means we've got two equations, at least two here. All right. So first of all, the variables. So the variables here are S for number of small snack packs, and I'll say L. And the reason we use a cursive L in algebra is so that it doesn't look like a 1. L is the number of large snack packs. So there's two sizes, large and small. All right, so one of the equations has to do with how many snack packs I sold, which is 60 snack packs were sold. The other equation has to do with how much money I made. So the one in blue, this is the simplest one, and that's just the number of small snack packs plus the number of large snack packs is equal to 60. So the number of small ones I sold plus the number of large ones is equal to 60. Now the other equation has to take in how much they cost and how many I sold. So a large snack pack is 5, a small is 3, and I made $220. So the equation there is going to be $3 times the number of small ones. 3 times the number of small plus 5 times the number of large ones is equal to $220. So there's my two equations. Now, I don't have either of these solved for a variable. So remember, let me go back a couple slides. If you don't have an equation that's solved for a variable, then you want to solve one of them for a variable before substituting. And so I'm going to use this first equation because it's the simplest one, and I can either solve it for S or I can solve it for L. It doesn't matter. So let's solve it for S. So I'm going to rewrite it over here, give myself room to work. S plus L. Oh my goodness, I can't write. That's what happens when you S plus L equals 60. So I'm going to subtract L from both sides. So what I get is S equals 60 minus L. Now I have something I can substitute. So I'm going to take this and I'm going to replace S in this equation with 60 minus L. Okay, so that's going to give me 3 times 60 minus L plus 5L. So again, I just replaced S with 60 minus L because they're equal. Equals 220. And I'm going to distribute here. It's a multi-step equation. And I get 180 minus 3L plus 5L equals 220. Combine like terms. So 180 negative 3L plus 5L is positive 2L. Two-step equation now, subtract 180 from both sides. So 2L equals 40. Divide both sides by 2. Running out of room. L equals 20. So I'm halfway there. I know that I sold 20 large snack packs. Now, I just need to find out how many small snack packs did I sell. So I'm going to take this, plug it into the other equation, and you probably already know what the answer is. I'm going to say S plus 20, so I replaced L with 20, equals 60. Subtract 20 from both sides. So S equals 40. So the answer is that I sold 40 small snack packs and 20 large snack packs. And again, you can check that. Obviously, the first equation says S plus L is 60 and 40 plus 20 is 60. So that works. The next one says 3 times S, so that'll be 3 times 40, that's 120, plus 5 times L, which is 20, so that's 100. So 120 plus 100 equals 220, so that works too. So there's your answer. So that's solving systems using substitution. This is a topic that a lot of students struggle with. So if you need to back it up and watch it again, go back and watch at least one other problem again if you're not really clear on what we did here. But I hope that was helpful to you and useful. If so, give it a like and a subscribe, and feel free to leave me a comment. So until next time, and happy Easter.